Okay, welcome everybody. Come in. There's plenty of seats. I'll give it a bit more. But in the meantime, I can slowly get started. So good afternoon. I hope you all had a nice lunch, or we'll have some after this. My name is Paco from Beckhoven. I've been working in the past years as a consultant at various different companies. And last year I decided to move to Switzerland, where I joined Hexagon, where I work for the Innovation Hub, and then specifically in a product called HXDR, which is a large cloud-based platform that allows users to create and explore large 3D models and all kinds of cool things. We also built the scanners for the 3D models. But most importantly, I really like code quality. I like talking about quality, I like developer experience, and that's also the reason why I'm here. But enough about me, let's actually talk business. So $316 billion, the nice amount. It was estimated cost of bugs in 2013 according to research done by students at Cambridge in 2013. So if we correct for inflation and all the necessary increases in prices, this is a very large number nowadays of money that we spend because we have bugs that need fixing. Now the cost of fixing a bug becomes more and more expensive the further we go into the development phase. Because if we can spot a bug during the requirements, we don't have to build it and break it and fix it again. Now, for this presentation, we're mostly going to be focusing on code reviews, which take place approximately in the coding and testing phase. Now, what is a code review? And I think this is sort of a nice definition. To me, it consists of three important parts. And the first one is, it's about finding and fixing bugs, the thing we mentioned just before, save money, save reputation. But there's more. It's also about learning and coaching. This is the place where you can learn from each other, you help to sort of conform to a uniform style, maybe some mentorship for new employees. And last but not least, indeed, code quality, which, because I like it so much, let's give it another extra definition, which is really about making the code conform to company standards, making it readable, efficient, matching all the conventions and best practices. So this sounds pretty good, right? Code reviews? Good. So we don't want to hear this. Now, of course, there are a lot of nuances. There's always nuances if you heavily invest in pair or mob programming, or if you are in a very mature team. But even then, it can still be useful to do code reviews. Now, the question is, how can we efficiently incorporate code reviews into our development practices through what we all probably know, pull requests? Or, let's do a show of hands, pull request or merge request? Pull request? Merge request? GitLab users? Probably. So GitLab is the one tool that mostly forces the term merge request. I will be using both terms because I'm using GitLab, but I like pull request better. But I'm still used to merge request. Now, there's a lot of version control systems out there that help us to facilitate this pull request or this code review process, because we can create the pull request, we can add comments, we can do suggestions, and we can resolve them. And there's also plenty of cool integrations and useful features that we can use that help us with reviewing. But we still often see the less pretty side. For example, you have the pull request that has the greatest title and an even better description that still managed to change 55 files in the project. Or the great feedback that we get from people, or the fact that we can wait endlessly for our reviewers to finally start reviewing our work, or one of my favorites, the curse of the small pull request. If you only make a small change, then suddenly everybody in the project has an opinion, but as soon as there's a bit more files involved, then it looks good to me in 5 minutes. It's always a surprise. Now for this, how can we address these issues? So through these presentations, I want to show you some best practices and how we can improve this. And I think the first part lies in creating good review-friendly pull requests. And for this, I'm just going to skip the implementation part. So we're going to assume that all our changes are concise, they are focused, they are tested, all according to spec. And another thing that I want to go over quickly is, I recently added this. It's a nice quote by Robert C. Martin, or I think we can also call him Uncle Bob, which is about we spent a lot more time reading code than we spend time writing code, which is also why it's very important to invest in making sure that things look nicely. And that also includes the pull requests themselves. Because the more clearly you describe your pull request, the less time the reviewers have to spend on figuring out what you're actually trying to do. Now, we start with a title. And I think a good title should be self-explanatory, like a good commit message. And fix bug is not a good title. But if we add a bit more context, then we have a nice title. So it's always important to try to be as specific as possible while also trying to be concise, which is quite a challenge. But we can take it one step further, because there's also something called, as I said, it's like a good commit message, and a good commit message should ideally also adhere to, say, conventional commits. For those who don't know it, it's sort of a standard on writing commit message in a certain consistent form, which is quite useful because often our commit messages, one way or another, or the pull request title ends up in the release notes, and then it's nice to have them in some sort of consistent way. And the cool thing is that you can also add linting so that your pull request titles become more consistent. And another thing, always include Jira reference or Jira project management, ticket references in your title. Most tools will make this clickable, and it's, I think, the first #1 thing that your change should have is a link to the ticket so that we can immediately see a bit more context. Now the next step, we have to write a description. And I think you can start with adding a bit more context. So basically see this as an extension of the title, add maybe some things people should to know, maybe some links to designs, or maybe a small summary of why this change is needed. Then you might want to make a small list to show people what they can expect in this pull request in terms of changes. Like, oh, I made some changes to the DB and I did some extra work here and maybe something here, so that people know what's expected. And one I particularly like is the why. And the why in this case, maybe not the best word, is why did you choose a given approach? Because while you're implementing your changes, your feature, you may go through certain thought processes. Usually there's not a direct solution yet, and you want to try some things. Maybe you went left, and then turned out that right might be a better solution. The fact that you tried left is important knowledge for the reviewer as well, because they now know, okay, I don't even have to think about left, because if you write down, oh no, left didn't work because reasons, then people know you considered that, and it's useful information because it's still in your head. Write it down, because in a week you won't know it either. So it's always good to write down any considerations you had, at least in the pull request, or at least the last place you should do it is in the pull request. Ideally there's ADR, like architecture, decision records, or other places, but this is also a great place. And examples. Screenshots if you work on the front end, but in the back end we can still add useful examples. We can add example requests and response so that users know what sort of, or the reviewers know what to expect of this change. Or if you just make changes to the database, even then an example query can be useful, because it also helps people in testing, trying to figure out how do I test this change. Oh, there's an example request, nice, I can just paste it, can tweak it a bit. It makes it the life of a reviewer much easier. Now, of course, the challenge is to keep this concise and readable. And I think because nobody wants to read a big wall of text. So this is where tools like ChatGPT can become very useful in trying to help you structure this. Another way is through templates. I really like templates because they give everybody some pointers on where to put the information, and people also immediately know where to look for certain information. And what I particularly like about templates is that you can add checklists. I didn't do this in the past, and since I started doing it, it's a nice place to put reminders of things that you should be doing, like you should have written tests. Are you sure you wrote the tests? This is always a good reminder. If somebody wants to be lazy, then they still have to check this box. And if they check the box without writing tests, yeah, that's impossible. But also things you haven't automated. Like not every pull request needs a change in architecture documentation, but maybe 1 out of 10 does. And then often that 1 out of 10 time you probably have forgotten, because the other 9 times you also didn't have to do it. So a small reminder here is always good. I find it very useful. You can make it as specific as you want or as generic, but try this. Now, having created this pull request, the next step of what we're going to do is we're going to start reviewing our own code. We want to be the first reviewer of our own pull request. The reason is that you can typically catch the most easy issues that you probably created when you have a new, fresh set of eyes on the pull request, because the pull request is usually just a summarized diff. So now you can easily see, hey, I made some changes to some file and it has some leftover line breaks that shouldn't be there, or hey, this file was changed, but I don't even need to be in this file, so I can revert those changes, maybe those variable names, could have been improved. Ah, wait, there's this comment that is not well formatted. Oh, hey, there's still a to-do in there. All these things you can quickly spot yourself so that somebody else doesn't have to be bothered about it. And the other thing is that you can start adding commands to your own pull requests for things that maybe not be expected or might need some extra explanation. So, for example, in this case, I deleted the file that turned out to be unused, but I wanted to make sure that's unused. So I did some research. I checked since when it was unused or when it was used. That is research. This is useful, right? Because I spent time on it. Maybe it was 5 minutes. Now, if I write this down, the reviewer doesn't have to do this himself as well. And it's not about cleanup things, but it can be anything. If there's some choice you made, the reason why you chose a certain annotation or why you decide to not do a null check here, just add a comment there, because you probably can expect reviewers to comment on them, then be faster than them, and write it down yourself. It makes it also much easier to review a pull request if somebody already did some extra annotations in the pull request itself. Like highlighting important parts, another one. Suppose you do a bug fix, but the file wasn't formatted. Now you have 20 lines changed in the file, even though there was only one line that was the actual bug fix. If you just add a small comment to that one line, this is the important part, the rest is formatting because somebody else didn't format it. Aside from the fact that it should be separate commits or maybe even separate pull requests, let's take the practical approach here. We're probably going to do that in the same pull request. Write it down. It makes the life of the reviewer a lot easier. And the last one is also specific questions. So you can add some comments on some algorithm where you're not sure, or variable names you're not sure about. Ask questions. Ask questions about team integration. So suppose you're integrating with another team and you're calling their API. Notify them, hey, what do you think of this integration? Does it make sense according to contract? Because then they immediately have the context right there. You can send them a whole pull request, but then they have to figure out where they have to be, and now they're immediately tagged in the right place. Now, having reviewed our own code, we're going to need somebody to actually start looking at it. And in practice, this is not always as easy as we hope it would be. Because in the ideal world, we don't have to ask for reviews. People proactively check the list of pull requests, or they are automatically assigned to people. But in practice, yeah, people are not always keen on reviewing. If you don't have this problem, I'm really happy for you. But unfortunately, I also have to deal with this on a daily basis where people are not always willing to review because task switching, etc. So one of the biggest problems with a message like this is what I call, it's not my term, but diffusion of responsibility, or what I like to say, shared responsibility is no responsibility. So if you throw a unpleasant message in a channel with 10 people, then all those 10 people will sort of point to each other. Oh, they're probably going to do it. However, this can easily be tackled by addressing specific people. Don't just throw it in, but tag the people you think might be interested or might be involved, or who you think they should be reviewing. And if they disagree that they should be reviewing it, they're probably going to tag another person, because they want it out of their hands. And this way you get a lot faster, a lot more turnaround on your message. And it's also good to add some context and a bit like where, wrong order. So it's also good to add some context, like in which area is this change going to be. If you just dump a link to a pull request, nobody knows where it is. They have to click the link first. Just tell them where it is. Somebody might be working in that same area, and then they might be interested, might be picked up easier. And the same is adding some sense of urgency. Like, is it something that is very urgent? It needs to be done before the end of the week because there's some feature freeze coming up, or there's no rush, we can do it later. It also helps the reviewers plan when to do the review. So a message like this is much more likely to get picked up and get a faster response and faster reviews than sort of a global message. And this actually goes further than just asking for reviews. Basically, this applies to any message you send in a team channel. If you need some information from another team, try to keep these rules in mind. Add some extra context, why you need it, when you need it, and also specifically tag people. If you need, maybe you need some statistics, maybe you need some help with something. It's always good to keep these tips in mind. Now, we started asking for feedback. Next step, people actually start giving feedback. Feedback which isn't always as great as we hope it would be. And that can be because some people simply lack the social skills, and then maybe they need to be made aware of the choice of words and how that affects people. But it can also be cultural differences at play. For example, I'm from the Netherlands. We're quite known to be direct. So that means that either I need to add some fluff around it, or it's good for the other team or other members to be aware that it's not intended as an offense. I'm not trying to offend anybody. I don't like to fluff around. I just tell my message. But it's good to keep these things in mind. And in the end, the most important part here is to always be patient and try to be the bigger person, because that's what being a professional is about, to not let the tone of voice affect your professionalism or how you do your work. Another thing you can encounter is sometimes the vague feedback that people give. They don't like something, or I don't like this name. I would always say try to ask for clarification or suggestion if any feedback is ambiguous or unclear, because you can go into this trial and error trying to figure out what they mean. You reread the comment 5 times, maybe they meant this, and then it turned out they meant that. It's time wasted. Just ask them. Saves you yourself a lot of time, and the reviewer also, because they don't have to go back and forth. Then there's the endless discussions. I think we all know that once you have 2 people that have a strong opinion and you put them in the same pull request and they have opposite opinions, it can take quite some time before they figure out and find some common ground, or not. Whenever you see that a discussion is getting to the 3rd or the 5th or maybe the 7th message, it might be good to just take it offline and have a discussion elsewhere. But, and that's the most important part, always report back. Also applies to Slack messages, to wherever it is, always report back what was decided. Because it's quite easy to, okay, we decided we go in that direction and we don't write it down. There will be other people who are wondering what was decided, and future you will also be wondering what was decided because you forgot. So future you will be very thankful if you also write things down. It's a great way of communicating. Now, not all feedback will be bad. There will also, of course, always be good ones as well. Feedback that's very useful. Things you missed, things you forgot, things you didn't know about. And it's good to show some gratitude there as well. Because maybe it's a junior in your team that's trying to review for the first time, and he finally found something, some improvement, and if you then, ok, thanks. Whereas if you try to be a bit more thankful and positive, it's sort of the positive reinforcement. Somebody is new, give them a bit of more positive feedback, and they're more likely, they get more confidence, and they're more willing to try more and more. It's always a friendly message goes a long way. Now, we're going to switch seats. So now we're going to be the ones who are going to give the code reviews. And I think the first important one is always that don't wait too long. Try to find a fixed spot in your daily routine. I would always suggest do the start of the day, because then you're still fresh. You don't have to switch context because there's no context yet, unless you take your work home, but I would advise not to. And then review it. Ideally, one of the things that I saw in some presentation, they said your backlog should be ordered by priority, which means that any task that has been picked up before the task you are going to work on, that previous task has a higher priority, which means that reviewing it should have a higher priority than starting a new task. I think that's always also a good point to do review, is when you just finish the task, let's start reviewing and then pick up a new task. The other important part is that giving reviews is also about taking responsibility. What you often see is that people, it feels like people do reviews just to unblock each other, but it's really about taking co-ownership of the change. You want to be part of the change, you want to understand change, and you want to make sure that it actually makes sense. And like you're signing off the thing with your name on it, and if it then goes down, that you also understand why it would go down and where you can help. So always see it not as an approval, but see it as I am now a co-owner of this change, which helps in the mindset. Then you want to get the context. So when you start reviewing, the first thing you're going to do is read the description. Because, and I've been here so many times, you skip the description, you go into the changes, and then halfway you start wondering why. Then you go back to the description, and then that's why. And also, we just spent quite some time, right, in creating this review-friendly pull request. It would be a bit wasteful and very annoying if people start asking questions of things that you just described. So read the description and also check the existing comments. Check existing discussions, because it's useless to have the same discussion twice in different places. You might want to hook onto a discussion, or, oh, it's already been addressed. Great. Now, the next step is how are we going to start reviewing this thing? We have a lot of changes. And I think this is according to Google have made a nice guide on code reviews, and they also always say, you start from the top. You start at the design, because any comments or feedback you have on the top layers will affect the layers underneath. So if the design is wrong, then it's not very useful to start commenting on some implementation parts, because that implementation might have to change anyway. So try to force yourself to start with the design, try to take the big picture first, and then you go down a layer. You're going to look at the functionality. Is the functionality in the right place? Do we have all the edge cases covered? And then the complexity. Does it make sense? Do we do weird algorithms here? Do we do weird things? And I added in bold, then we start looking at tests. Because I know from experience, tests usually also alphabetically sorted, so tests are always the last part of the code review, the pull request, and it usually doesn't get the time and attention it needs. What you often see is that people think, okay, probably the tests have passed, I just spent quite some hours on reviewing the implementation, the test should be fine. But the problem is that a bad test suite will affect you. Whenever assertions are missed, which is one of the typical errors you see, is that people forget to assert everything, maybe because they were lazy and they didn't want to assert all the fields, or maybe they just simply forget. And those missing assertions are sort of usually the opening for a new bug, because you make a change in the future and then you forget to cover this scenario, but there was no assertion, so the test will pass, and it won't fail, so you won't know. The bug makes its way. So always spend enough time on the tests as well. Please have a look at those, because they never get the attention they need. And then, at the very least, at the very end, then you can start complaining about style and documentation and nitpicking about all the tiny things, which in the end of the presentation, we're going to address in a different way. Now, there's tools to help you with this. One of the things that I really like, so in the left, GitLab, for example, you can inline the code coverage in your diffs. So you immediately see whether changes were covered or not. Because ideally, we want to know that when we review whether the implementation was actually tested. Now, we have two options. We go through the code coverage reports, which, to be honest, I haven't done that very often, where I take a code coverage report and the changes and put them together. But more typically, if you have all the information at hand when you open a diff, that's very nice. So if you use a tool like GitLab, and I think it's also supported by Azure DevOps and Bitbucket, try to see if you can get the code coverage in line. It's really useful to immediately spot differences. And the same, there's also tools like Sonar, which can integrate in your pull requests, which can automatically add commands to certain style issues, so that you sort of skip a layer of commands that you have to do. It saves some time. But not everybody is able to access these tools or change these tools. But we have one tool which we can all use, and I think that's the best tool, which is your own editor. So suppose this is a change, not super relevant, but I made some small change. I introduced some check and an early return, and I don't use a constant anymore. Now, if I would look in a diff, this sort of looks okay, possibly. Maybe you can say some things about the style. But if I open it in my editor and I see a bit more context, and I immediately see, hey, this constant is no longer used. I didn't see that in my diff. I can see that, hey, dot equals, maybe we want to use is empty. Or the fact that it's not covered. Because even in my editor, I can run the tests, and then I can see, say, suppose you use IntelliJ, but most tools, I think, offer the option to inline code coverage. I can immediately see, we need another test case for this. Maybe you want to write a test case, please. Or, and the nice thing about IntelliJ, at least, if you check out a branch, or in for most version control systems, there's an integration, so you can actually start commenting from your editor, which I think is really nice, because that's the best place to navigate around the code anyway. You can easily move around and see if things make sense. Now that we went over the code, we probably might want to comment a thing or two. Maybe we found some things that are not that great as we hope. And that's also the art of doing this in a friendly way. And what you sometimes see is things like, you chose the wrong framework. Use X that is actively maintained. Now the choice of words here, the you. The problem with you is that it's often seen as a direct attack, or it can be interpreted, you did something wrong. Which makes people defensive. And if people get defensive, they're less likely to cooperate, but more likely trying to prove the case that they might be right. And the same is about making bold statements. If you make a bold statement, people will find it a challenge to prove it wrong, and if they prove it wrong, that makes you look kind of stupid, right? Because you just made a hard statement, very confident, it's wrong, and then it turns out it was actually not wrong, which is kind of silly. Whereas if you turn it around and ask a question, why did we choose this? Give somebody the chance to answer, and maybe in the answering process they figure out, that makes sense. Right, maybe I shouldn't have done it this way. Which means that people are, again, more likely to cooperate. So a message like this, why did we choose Y? Understood that X is more actively maintained. You still can convey your hint, even though I would say save that for the next message. But it sounds much more friendly. And the whole thing is that, given that pull requests are not always the most positive place, it's good to keep things a bit nice. And it takes some time to get used to this. The nice thing about we as well, what I forgot to mention, we is also about collective ownership, because in the end we're all making these changes together, we're all working on the same project, and we all have the same goal, which is to write nice software. And it doesn't mean that we actually did the change together, but we did reason about the change together, because we were probably both in the meetings about this feature. Now then, the other challenge is to try to stay specific. Words like this or it or anything that refers to something you said before can be interpreted in many different ways. And as soon as there's multiple interpretations possible, there's room for miscommunication, which is also a great source for either bugs or time wasted. Always try to be specific in your comments. Reread your comments, reread your messages. Just spend it, take a look at it again and see if there's no other interpretation possible. To get back to the quote that we had before about from Uncle Bob, where he said we're gonna write it once and reread it 10 times. That goes for comments as well and for messages, because somebody else will also look and try to figure out what was said there. And it's always easy to say something is wrong, I don't like this name, we had this before. Try to provide an alternative or a solution or some direction on what you're kind of expecting, rather than leaving somebody sort of pointless, now I need to figure out what he did want. Try to be specific. Now, another new tool that most version control systems have is the user suggestions. So you can select some lines of code, and then you open a command, and then there's a button. So in GitLab, it's that button, where you can make changes in line. And the nice thing about this, there's a sort of a time saving in two places. The first one is that you immediately make clear what you want, and the person who makes the changes can immediately apply them, because usually here there's an apply suggestion button, so the change is automatically done. This means that the person who makes a change doesn't have to go in the code base and change the line, and the reviewer doesn't have to go back and check if it was done correctly, because it was done as I just specified. Now, the downside of suggestions is still, though, that if I suggest to rename a variable, right, there's also usage. So either we suggest to change all of them, or we add a note like don't forget to rename its usages. But I think it usually, to me, this reads much nicer in trying to figure out what people meant, because it's immediately in the context. There's also something called conventional commands, besides conventional commits. And even though I think it's a bit extreme, I don't always use it. I try to start using it, but then I forget, and you get some inconsistency. The nice thing about it is that you get consistency, and that you get sort of parsable commands, and people immediately know how to read them and what to expect. Praise, okay, praise. I don't need to really care about what it is. Well, I mean, I like to read it because it's probably something nice. But I think the most important one from this whole thing is the identification of whether something is important or not. When you mark something as a nitpick, I think that's always a great example. Okay, you probably might have some opinions about naming that could be slightly improved, even though we both know that it doesn't matter, right? Whether we choose A or B, most likely it's going to stay the same. And then you leave it up to the reviewer to decide what they want to do with it. Sort of a non-blocking command. Like, I would like it like this, but if you don't do it, it's also fine. We're still friends. Continue your work. And then the last one, praise. So as mentioned before, code reviews are not always place. You mostly hear what you missed or what you did wrong. But it's also nice to hear that the things that you did right. And this might not be the best and most positive way to look at it, but it's always good to at least force yourself to add 1 or 2 positive comments. And at some point, if you train yourself, this becomes easier. Maybe you found there's always a chance you learn something new. Maybe there's some new feature being used, or maybe there's a new library method that you didn't know about. Maybe you just really hated implementing this feature and you're very happy that somebody else did it, or somebody took the effort to write some extra tests. It's quite useful. And then if you add this positive message, the whole thing is that the positive message goes a long way. In a time where you see a lot of imposter syndrome, where people are a bit insecure, it really helps boost people's confidence by also giving some compliments. And in the end, also, more positivity means probably a more happy team, and a more happy team is a more productive team. Now, having covered the code review part, there's one more thing, bike shedding. So I already mentioned the code style and the style documentation. Bike shedding is also known as the law of triviality, where it comes from a discussion that some architecture board had about designing a power plant and the bike shed of their office. And for some reason, they much better talked about the bike shed because it's easier to read about. And the same you see in pull requests as well. It's much easier to add comment on the small things rather than to argue about the design, for example. And the problem that all these small code style issues, they distract us. They distract us from the bigger picture. You have some people that think, oh, I added 5 commands because there's probably 5 code style issues, and now it looks like I reviewed it and I'm going to continue. And also people will get distracted, right? Because if you start going through the code, another line break missed, another formatting issue. So what we want to do is we want to get rid of this noise by automating parts of it. So I want to go over some tools. I can't demo them because I don't have enough time because there's too many tools. But at the end, I will have some links for these tools. So the first one, error-prone. For those who don't know error-prone is a tool that compile time checks for typical programming errors and some mistakes. And the nice thing, it has automated fixes. So whenever you want to start using error-prone, you can just apply all the fixes it found automatically. In opposite to, for example, say checkstyle. Checkstyle mostly complains, but it doesn't give suggestions. Now, how does this look? For example, there's multiple ways to filter a list and check whether an address is null. One of the ways is to do a null check. Another way is to use this object's non-null reference. And in the end, actually, it doesn't really matter which one you use, as long as you use it consistently. And if you have a rule that automatically says we do it this way, then we don't have to have a discussion about it. We don't have comments about this. The same, for example, say big decimal value of 0 or big decimal 0. They do the same thing. Well, let's automate this and have one way to do it. And besides, so it goes for many ways, the way you filter a list or anything. But it also can find some bugs. Like what I encountered was issues with logging. In this case, we used curly braces. This won't work, right? Because it's a string, and string.format needs %s rather than the curly braces. So this is a bug that it found because of some weird error scenario. I found this was kind of nice, but the other one that I encountered, does anybody know what's wrong with this line? Exactly. So the thing is, there were multiple things that are wrong, of course, but assert that without anything behind it does nothing. So this is an empty assertion. One that's easily missed if you look at it, because hey, there's some equals in it, even though ideally we would say assert that some pojo.getID is equal to expected ID. We could take it a level further, but error-prone is able to spot things like this and automatically apply a fix as well there. So it would automatically say, oh, we add is true at the end, and it's good. And there's a lot of rules around this. Now the nice thing is, so error-prone is initially was created by Google, and it still is maintained by Google, but also a company from the Netherlands, Picnic. They added a much larger set of rules. So if you use both Picnic and error-prone together, you get a very opinionated tool that will tell you about doing things in one particular way. And the nice thing about doing it in one particular way is there's only one way. You don't have to have discussions about it. And when you start using this, the default rule set might not work for everybody. It might be too strict, it might not fit your company standard. I know that Picnic is, for example, very focused on the Google Common or Google Guava kind of things. And if you don't use Guava, then you want to disable all rules that suggest you to do things in the Guava way. Also, there's some issues with some parts of Lombok. So the more nasty things you do with Lombok, the more chance you are that you might run into some issues. So we also use Lombok, and especially if you start going into the super builder thing, you might run into some issues with some rules, which means you might have to disable them. Then there's Open Rewrite, which is slightly different. For those who don't know Open Rewrite, please go check it out. It's a great tool for doing large-scale migrations from, say, Java 17 to Java 21 or Spring upgrade. Spring also supports this. There's a big set of recipes to say if you want to go from Spring 2.8 to Spring 3, you just run the recipes and then say all the code changes all over your code base are mostly done. You only have to do some small tweaking, which saves you a lot of time. Now the reason why this comes back in the context of code reviews is what you often see is that people do rolling upgrades. So okay, we're going to move from Java 17 to Java 21. We're going to update the JDK and everything will now be Java 21, but we're not going to do all the change because we don't want to go manually over each switch statement. We'll do that when we encounter them. But it also means that every time you encounter them, you will add more noise to your diffs in your pull request, or you get people asking, oh, can you also fix this because you changed this one line, and then please also fix those other 20. that adds noise. Whereas if you have a tool that just does it at once over your code base, you're done, and you don't have discussions about it, and it saves some noise in the pull request again. Then, and I think the biggest noise creator usually in pull requests is also formatting. I would say it's the least relevant thing if you all just do it right, and it's the most easy thing to automate. And if you choose a formatter, ideally, the more opinionated the formatter is, the less room you have again for discussion. Because in the end, does it really matter, the code style? I mean, yes, you want to be consistent. I think that's the most important part, because we always go from one company to a new company. They do something slightly different and we'll get annoyed by it because it's different from what we know. But then we move to the next company and then again, now we have to change again. We liked what we had before, what we didn't like because we liked what we had before. So in the end, it's good to have something that's very opinionated. And the one I really like, for Java at least, there's Google Java format by Google, according to their Java style guide. And this one is so opinionated that there's effectively no change possible. There's only one way to format things. This has, of course, disadvantages that sometimes it might be slightly suboptimal to read things, but on the other hand, you never have discussions about it. Because in the end, no formatter will be perfect. If you want to have a perfect formatter, you're going to need some space. You need to have some freedom to align things, because in one case, a builder wants, you need to have it on. So suppose you use a builder, you want to have a line break and have each operation a new line, but if there's only like 3 things, you want to do it on one line, and you get very complex rules, which are often not automatable. But the nice thing about Google Java format, it's very automatable. There's tools like Spotless, that offers formatters for many different languages, because in reality our projects will contain many different languages. It won't just contain Java, but there will probably be SQL for migrations, some readmes, some JSON files, maybe for the tests, and probably if you have some front end in there, maybe some TypeScript, maybe some Python scripts for migrations. The nice thing about this tool, it has formatters for all of them included, and you can also some guys switch formatters. So for Java there's 5 different formatters available, which you can automatically run in your CLI, maybe as a pre-commit hook, or maybe you want to do it as part of the build and then let it fill if the formatting resulted in a diff, so that you don't have to be bothered about formatting anymore. When I joined, we didn't have a formatter, and I noticed that every time I was opening a pull request, first thing I did is open the change in my IDE, select the changed files, and click the format button. Then I would have a list of files that they forgot to format, and I could command that in the pull request, which is an action that takes about 1, maybe 2 minutes in total, which is time wasted. And if you invest a little bit of time in standardizing this, you don't have to waste the time anymore. In addition to that, there's the tool called checkstyles, more widely known. If you cannot choose a very opinionated formatter, which unfortunately I couldn't convince the team because I was just new to start a very opinionated formatter that might not always be as they like. But then the alternative is to use checkstyle, where you can sort of manually create enough rules that at least fit your company's code style, so that you, again, it's automatically formatted, or it's at least automatically enforced, and you don't have unformatted code in your editor or in your diffs. No more unformatted code in your projects anymore, because the problem is, whenever you make a change and something is unformatted, and you are the one formatting it, we get back to the bug that I mentioned at the beginning. You have 20 lines change, even though you wanted to only change a single line. And the nice thing about checkstyle, it can also have some opinion about naming and about ordering of methods. So you always want the public methods on top. Maybe it depends, right, on what you want as a team. Then another one, ArchUnit. ArchUnit is a tool to enforce architecture guideline and also naming conventions. And ArchUnit is at the core of Spring Modulith as well, which is a tool where you can have sort of, well, your monolith, but then still enforce rules to make it into separate services. That part can be ignored, but to give you some example, you see it here as well in this code here, is that you can say that any code that, say, is in the source package should not be allowed to target the forbidden package. And in practice, that could be if I have a controller and a service and a persistence, so a non-hexagonal architecture. But a more classic one, we always want to reason that the controller package cannot be accessed by the persistence layer. The controller package should only be allowed to access the service layer, and the service layer should only be allowed to access the persistence layer. You cannot go directly from controller to persistence, and you cannot go from persistence to service. But there's more. You can also use this to make your names consistent. So one of the things we have is interface names. there's many different ways to do interface names. You can prefix an I at the beginning, you can add interface at the end, or you can say, interfaces shouldn't have a special way to indicate them, or implementation should end with impl. In the end, it doesn't matter, but the most important part is that you're consistent with this so that you don't have these discussions in pull requests. You don't have to remind people about it because there's a tool that enforces this, or that, say you want all your controllers to be posted with controller. With this tool, you can easily say any class that is annotated with strings @rest controller should end with controller. And now all your controllers at least have consistent naming and you don't have to think about this anymore. Now the nice thing with Arch Unit, it already comes with a very large set of predefined rules to capture some common mistakes. And when you start using this, create a shared module and share this module across all your different projects. It's a really nice tool, and there's a really nice integration to say, okay, I want to import all the modules from, say, this rule. So I want to have a rule for packages, and I have a rule for naming classes, and I have some rule on anything that's passed as a parameter object, which we have in a specific package, should always be postfixed with the name query. Whatever you can think of, just create a shared module and then share this across all your projects so that you have this consistency everywhere. Then, okay, all these tools, quite nice. When we start, maybe we want to start introducing them. Now, don't do it all at once and throw it over the fence, because then everybody will be at your desk when the build fails because they don't fully understand. Try to get the team on board, and this is really important. Create some sample pull requests, not merge requests, or merge requests, it's also fine. And add comments to all the rules. So in this case, I introduce error prone, and I notice, okay, these changes, this is because of this rule, this is because of this rule, what do you think? And then people can start commenting on the individual rules. I don't like it, I do like it. What about this scenario? Why was this changed? And then you create this, again, this shared ownership, which is really important because then people are on board and they're willing to use it. And in the end, it helps in the adoption. Then also it's important to make sure that you centralize your configuration. So especially tools like error-prone and checkstyle, they have their configuration in a POM file, which can be quite big. You don't want to duplicate this all over the place. Make it centralized. And if you don't have a parent POM, this is a great opportunity to start using a parent POM because it also helps in uniformity across all your repositories. And make sure your configuration is there. Now, to conclude, write descriptive pull requests. Review them yourself first, because you always will find something that could be improved. Be specific in your communication, and so be friendly. Try to find some positive things as well. Keep each other happy. Use the tools that your version control system have, or use your VCS features, like the code coverage differences, maybe integrated with Sonar, and use your editor to help you review. And then the most important part is to stop bike shedding and start automating. Thank you.